Chapter 36, this is the major ecosystems of the biosphere. There will be roughly 12 questions coming from this. I'll try to point out the high yield points as we make our way through this. Again, here are just some objectives. Knowing the objectives, being able to answer them, being able to describe them to a friend is probably a good study method that I would encourage you guys to use. I think that it would be highly beneficial as I take most of my test questions just from the study objective. So here we have just an overall description of climate. So what is climate? So climate is just pretty much the weather pattern. It's the weather conditions in a particular region. So there's two things that really are going to dictate the climate. Again, this is kind of self-explanatory if you just think about it sensibly. The temperature and how much rain. So you guys know Kentucky weather is it's a little bit difficult sometimes, isn't it? So the climate here kind of varies, but it's going to be different than a place like Florida. They're going to have a little bit warmer climate, a little bit more rain, as we'll see later on. So temperature and rainfall are influenced by the following things. So topography and proximity to body waters, right? So how high or low a place is would kind of dictate um, the climate of that area, and variations in the distribution of solar radiation. So this is just saying how does the sun distribute? So as you're closer to the equator, the sun is going to hit at a different angle. It's going to be more focused due to the tilt of the Earth on its axis. So it kind of makes sense if you think about it. So depending on how close you are to the equator will depend on how much the sun is able to hit you. How much direct sunlight are you getting? And these things will affect the temperature, and the temperature will affect the climate. And depending on how high or low, depending on the elevation, as well as depending on how close you are related to a body of water, will um, kind of dictate how much or how much rainfall that you may get. And that kind of makes sense. That's just because of evaporation, right? So as the sun um, causes the water to evaporate, that's going to eventually condense, and then again that'll just fall back to the land as precipitation, right? The water cycle, like we previously just described. So the two most important things I would say to take from this slide is just knowing that temperature and rainfall affects climate. As you can see over here, I have just an example on a graph. Just depending on the month will depend on how much rainfall is present within Manila. And Manila is located within the Philippines. So this is going to be a more tropical area. As you can see here, is the warmer months, typically summer. They're going to get a little bit more rainfall here. And this also is reflected by temperature as well. And you see peak rainfall here is happening. It's actually not at the hottest time, but you can see that more rainfall does occur as the temperature increases. So here we have just the climate zones. As you can see, as the sun hits directly on the equator, you're going to have more of a tropical area. And as you can imagine, that temperature is going to be a little bit hotter in these areas. So here, the text says that the Earth is spherically shaped, and because it's spherically shaped, the sun's rays hit more directly at the equator. And again, we know that the equator is at 0 degrees latitude. The tropical areas near the equator are typically are warmer than areas that are away in the polar zone, for example, in Antarctica or places up towards Iceland, Greenland, places like that. So seasons are determined by the tilt of the Earth on its axis. That's important to know. It makes sense because as we're entering into the winter months, the northern hemisphere is going to be tilted away from the sun, and that's why we have seasons. It's just because of the Earth on its axis, right? Describing this a little bit further, the Earth completes one rotation on its axis per day. So depending on The rotation will kind of dictate the flow of warm and cold air, and there's typically three large circulation patterns. I didn't really go into this, but it is an interesting read if you guys want to read that. It's in your book. But the direction in which the air rises and cools will kind of determine the direction of the wind. So the equator, for example, is going to at the equator, the sun heats the air and evaporates water, and the warm, moist air rises and loses most of its moisture as rain, resulting in the greatest amount of rainfall occurring nearest the equator. That makes sense if you guys have ever been on vacation in Florida. It's closer to the equator. I'm sure that you've seen um, in the forecast a lot of rain. Sometimes as you'll go there and you think, "Oh, this is going to be a terrible day for the beach." Um, and usually, you may get like spot showers here and there, and that's just because it's warmer there. And as it's warmer, more evaporation is going to occur, which allows condensation to occur and then precipitation to follow. So, mountains will kind of dictate. Um, will kind of dictate climate. And as we previously discussed, the term topography just refers to the physical features of the land. So there's these two things called windward side and the leeward side, and this is just in reference to rainfall. So as you can see here on the right hand side of the screen, we're going to uh, begin discussing something called the rain shadow effect, and this is going to be described through this picture as well as the text on the side. So as you can see here, air is blowing up and over the mountain. And as the air is blowing up and over the mountain, it kind of rises and cools and allows this condensation to occur. And as you guys know, as condensation occurs, it's eventually going to fall back as precipitation. Because of this, one side of the mountain will receive more rainfall than the other side. So we have this cool wind blowing up and over one side of the mountain. So as it's moving up and over, the condensation occurs on the windward side, which is going to typically receive more rainfall than what we call the leeward side. So the rain shadow is on the opposite side. So uh, this the text says that this can occur within the Hawaiian Islands. There's typically uh, sides on the windward side are going to receive more rainfall than they do on the leeward side. So, just two terms to be familiar with. They are important for examination purposes as well as knowing the rain shadow effect. So, knowing that on the windward side you receive more rainfall, and you receive more rainfall because the wind is blowing up and over, it's allowing it to cool. And once the cooling occurs, condensation happens, and the condensation causes precipitation to follow. And on the leeward side, uh, there's no rain, so this is called the rain shadow effect. I thought this was very cool. Whenever you visit the beach, like I just recently did, you can often feel that cool breeze blowing in, and you're wondering why does that happen. So it's actually because the oceans are slower to change in temperature compared to that of the land. So the land heats up a little bit quicker, and because it has that effect, the rising in the cool air allows a cool sea breeze to blow in from the ocean. So it's this change in temperature from um, the water to the land that causes this cool wind to blow in off of the ocean. This is another important slide, knowing the monsoon effect. So, depending if you're in India or some of the surrounding areas, such as in the Asia territories, um, there's something called the monsoon effect, and this is just due to the rise in warm air. So, as air rises and warms, it loses moisture, and we know that moisture is a result of condensation, and as condensation can occur, precipitation occurs. So, rainfall is particularly heavy on the windward side of the hills after this. And again, we know the windward and the leeward side. So in India and some other countries in Asia, the land heats more rapidly than the ocean. Because it heats more rapidly than the ocean, there's a difference in temperature, right? Which causes a gigantic circulation of air. And again, we've already kind of discuss that. And because there's a giant circulation of air, this air is going to um, lose some of that heat within the moisture, and the moisture is going to eventually condense, and it's going to fall back as precipitation. So there are typically times during the year when monsoons are going to be more prone to happen. So this is another objective slide. So I want you guys to be able to kind of identify just the major geographic distributions and know their defining characteristics, as well as summarizing the key characteristics of the major terrestrial biomes. So what is a biome? A biome is just a major type of terrestrial ecosystem. So different biomes, there's tundras, which is going to be typically colder, more northern areas that contain permafrost. There's going to be areas such as the tropics. Then you can have um, desert areas. We'll kind of go over those. So, what defines a biome? And it's really just because of the climate, right? And we know that climate is dictated by temperature and rainfall influences. And we know that the temperature is typically due to the direct sun rays that come off of solar radiation from the sun. And we know that this causes different amounts of condensation to occur, which influences the rainfall, right? So, knowing temperature and rainfall is typically the two biggest uh, influences of what a biome is made of. So here's the tundra. Again, I previously discussed this. Knowing what is the major key characteristics of the tundra is probably pretty important. It's an easy exam question that I could write. So just knowing that it is in the northernmost area, so I think about are really polar areas, and it contains grasses and sedges of dwarf woody plants. Right, they're woody because they don't contain a lot of leaves, and that's just because there's not much photosynthesis occurring here. Because why? Um, uh, there's not much nourishment to go around. So most of the water in soil is frozen year round. That's due to permafrost. Um, So there's different types of forests. So we have the taiga. I think that's how you pronounce that. This is a coniferous forest, and this has typically less rainfall than other areas. The temperate deciduous forest. This has uh, they're able to gain and lose their leaves during the spring and fall. And then you have the tropical rainforest. And the tropical rainforest, I would argue, is one of the most interesting of the biomes because it's able to contain the most complex and productive of all biomes. And that's important to know that it is the most productive of all biomes because it contains some of the most interesting species and some of the most species in the world. So some that we still haven't even discovered today because it's just so vast and so complex. So many of the plants in the tropics are called epiphytes, meaning that they grow on other plants. I thought that was pretty cool to include. So shrublands are uh, this is kind of important to know. They're usually along the coast and have dry summers and receive uh, most of their rainfall in the winter. Grasslands, you have the savanna, the tropical grasslands support the greatest number of different types of herbivores. And then we have deserts. Deserts are uh, typically what you think of, right? They contain cacti, which are succulents, meaning that um, they're able to adapt and to conserve water. So whenever I divide these up, I think of shrublands being on the coast, and I think about grasslands um, containing the greatest number of different herbivores. Makes sense because herbivores eat plants, and the grasslands are rich in uh, a variety of vegetation. Then I think about deserts. Deserts contain cacti. They're typically in areas where it's going to be very hot. They don't receive a lot of rainfall. So just knowing these three would be important. Compare the characteristics of freshwater and saltwater. I don't necessarily know that we go into that. I guess we do in terms of the different zones, and those will be important. And recognize the difference between the pelagic and the benthic divisions of the ocean. So we'll begin discussing freshwater and talking about uh, the deep temperate zone lakes. So eutrophication happens, um, which is just a large input of nutrients into a body of water. And this occurs through various different means. This can occur through just the different wildlife living within the lake itself. It's important to know about spring overturn and fall overturn. And I thought this is cool. This is when nutrients from the bottom of the lake layers are redistributed. So, a redistribution of uh, nutrients can occur, and that's called spring overturn and fall overturn. The entire body of water is cycled. I didn't go into specific details on that, it's a little bit too complex for us, but I thought this was a cool tidbit. This is probably more important, definitely testable, just because it's an easy examination question to write. Lakes and ponds have three zones. I actually did not know this until I started studying up on it, but there's the littoral zone, the limnetic zone, and the profundal zone. So the profundal is the bottom dwelling, and the littoral zone is at the beginning. It's where rooted plants and clinging organisms live, and the limnetic zone is where plankton and fish live. So just knowing the zones and knowing where they're at and location of the littoral zone is the most proximal. It's going to contain the plants and the area and clinging organisms. The limnetic zone contains plankton that's unique, as well as the profundal zones kind of near the bottom, and it is going to contain the bottom dwelling organisms such as the crayfish and mollusks. So there's something called the upwelling. This is we're beginning discussing about oceans. Oceans play a major role in determining climate of land biomes, and that makes sense because oceans are going to help move warm water from the equator towards the poles. This occurs through something called upwelling. This is when cold offshore winds cause nutrient-rich water to rise and take the place of warm nutrient poor water. So this is just a mixing of water, which you have wind blowing along the coastline, as you can see here on the right hand side. This is just causing the cold water, which is rich in nutrients, to replace this warm water that is poor in nutrients. So here we have begin discussing marine life further, of talking about coastal ecosystems. And when you live along the coast, you have the potential to produce some of the more unique biomes, and I think this is cool. The estuaries, uh, they're pretty much one of the most productive um, biomes present. Right, the coral reef is extremely important. And for example, I just recently went on a cruise, and they talked about being next to the coral reef and not disturbing it because it's home to so many different organisms, and the coral reef itself is able to provide a habitat for just a large amount of organisms. Disrupting just a little bit of that may completely disturb that ecosystem. So here I just have coral reefs contain a tremendous diversity of species and play an important role in the health of the ocean. Don't go into specifics about that. I just want you to know in general the coral reef is important. Coral reef is responsible for just providing a habitat as well as promoting the health of the ocean in general. I do want you to know the term estuaries as it's pretty important. These are just near the mouth of a river, and they're called nurseries of the sea. So these are your salt marshes, your mud flats, and your forests. So estuaries are near the mouth of a river. That's pretty much what you should know. So estuaries kind of nurture the river. I want you to know this as well. Um, know the different divisions of the ocean. That's an objective. That's definitely testable. You've got a division called the pelagic and the benthic division. The benthic division is going to be just your ocean floor. As you can see over here on the right hand side of the screen, this is making up all the benthic. This is your bottom portion. Going into the abyss, this is where it gets into the abyssal pelagic. And there's different zones of the pelagic. So we've just had the benthic division, which is predominantly the bottom portion of the um, continental shelf, and it's divided again into the sublittoral, bathyal, and abyssal, as you can see over here. But the pelagic is divided into three different layers as well. You had the epi. Epi means around. It's at the top. The epipelagic zone receives adequate sunlight and supports the most life. And that makes sense because just due to where it's located and its proximity, as you can see here, it's going to receive the most sunlight. And meso means middle. So you've got the mesopelagic, and then you've got the bathypelagic. Contain organisms adapted to minimal sunlight and no light, respectively. So, as you can see here, we're getting a little bit deep. Here, we're about 200 meters, which is still getting a little bit deeper. But as you can see here, sunlight's not going to be able to reach. As you can see over here on the left hand side, that as you get deeper, the water gets a little bit colder as well. So you've got the epipelagic, which is going to receive adequate sunlight, which makes sense. It's near the top of the ocean. The meso, which is in the middle, and the bathypelagic, which is going to be receiving supporting organisms with minimal to no sunlight. And that all makes up the pelagic, or the open waters. And the benthic division of the ocean is going to be divided also up into three layers. You got the sublittoral, the bathyal, and the abyssal plain in the abyssal zone. So kind of cool. This is just a brief discussion about hydrothermal vents. I didn't even know they exist until I think a couple of years ago, whenever I was studying this. Underwater hydrothermal vents are formed when seawater percolates through cracks. So you've just got this crack in the ocean, and this magma, which is present here, is reacting with water to produce hydrogen sulfide, as you can see here on the bottom hand side of the screen. So you have this high temperature here mixing with water, and it's whenever this water comes into contact with this sulfate from the magma that you're able to produce this um, this hydrogen sulfide. So, and that really concludes chapter 36. If you guys have any questions or need anything at all, please feel free to reach out. I'm willing to discuss anything or go over anything I can do to help you guys. Thank you so much.